OK, so now it's time to give printf some mismatched arguments. Remember, the attacker controls what we put in buff. So let's have the attacker write some percent formatters. This attacker wrote %d, %s. Those are some percent formatters. And so now when we call printf on buffer, which contains %d, %s, we're going to have mismatched arguments, and bad things are going to start happening. So let's think about what printf is thinking while it reads this input that was provided by the attacker. So the printf function goes character by character, and anytime it sees a % symbol, it goes on the stack, takes the next argument, and plugs in that argument into the % formatter. That's what printf does. So we start reading, and immediately we see a %d. OK, well, that means decimal. It means integer. So I should go on the stack, take the next argument, and match it up with the %d and print that value out, because %d is really a placeholder for whatever that argument is. So here's %d. I go on the stack. I take the next argument. Well, what is the next argument? Well, the 0th argument was buff, and that's right here. So if the 0th argument was buff, then the next argument must be 4 bytes above that. Remember, that's how we push arguments on the stack. We push them one by one in reverse order. So if buff is the 0th argument and it's here, well, then arg1, the next argument, it must be up here. Except we never actually pushed an argument, so who knows what this is? Here it happens to be secret number, and so printf thinks this is an argument that printf passed in. But printf didn't really pass in any arguments, or rather, vulnerable didn't really pass in any arguments to printf. There's a mismatch. So printf doesn't know about the mismatch, goes on the stack, says, well, this looks like arg1. This is where it would be if it was there. It's not actually there, but printf would go here to look for it if it was there. So all of that is to say, we go on the stack, we take the next unused argument. It's 4 bytes above the 0th argument, and it just so happens to be secret number. So I will print out secret number as an integer to match up with the %d. So instead of printing out %d, we print out 42, because that happens to be the argument that matches up with the %d. So printf expects there to be 2 more arguments, but there actually aren't. So we're going to go look for those arguments anyway and potentially find some secret values to leak. So 42 gets printed. OK, what comes next? Well, printf continues reading this input character by character, and it immediately sees another %. OK, well, I see %s, and s stands for string. So what that means is I got to go on the stack, take the next unused argument, and plug that in to %s, substitute it in for the %s placeholder. So what have I used so far? I've already used this arg1 with the %d, so the next one that hasn't been used yet must be 4 bytes above that. Must be right here, which I've labeled arg2. So this secret string value should be substituted into the %s. And s means string. And strings are pointers to the start of a character array. So I read this as an address. I go to that address, and I start printing characters until I see null. So I print P-A-N-C-A-K-E. I see the null, and I'm done. So in total, the %d, %s caused me to print out 42 pancake. Both of my secret values got leaked because the attacker provided a %d, which matched up to secret number, and a %s, which matched up to secret string. They weren't supposed to be arguments, but printf didn't know that and treated them like arguments anyway.